Hello everyone, this is Mengyao Li from Politecnico di Milano. Now I'm working for the WatchEDGE project. WatchEDGE is studying an advanced edge computing architecture which supporting AI-based image processing applications which can be distributed on the different sites. It is adopted for environment surveillance for the agriculture and the wild animal. I am working on this orchestrated architecture. The service orchestrator is from our colleague NextWorks. I am doing for the REST API between the service orchestrator to the SD-WAN controller. I'm focusing on the northbound interface. Then this is a simulator I built, especially for the SD-WAN environment. Due to the SD-WAN environment, the connections are not guaranteed, so we need a simulator to estimate how many link capacity and how many node capacity we were able to use. That's it, thank you.
Hello everyone, my name is Jean-Pierre Astiguian and I'm a PhD student here at Politecnico di Milano. Our aim is to enable real-time wildlife monitoring with minimal usage of computational resources found on far-edge devices, subsequently minimizing environmental impact. In particular, we are working on models that detect animals of various classes, such as wolves, boars, and deer. These models not only detect, but are also capable of self-training via semi-supervision. The embedded model would be able to detect, store, and automatically label images, from which it would be able to learn afterwards, refining its performance over time. Here, for instance, we can see an example of the aforementioned, our custom modified YOLO pipeline, and of course the power supply, again created by Politecnico di Milano, our custom build. Thank you.
Hello everyone, I'm Greg Russo, PhD student at the Department of Electrical, Electronic and Computer Engineering at the University of Catania. As a part of the WatchEDGE project, together with Dr. Cristian Grasso, we have been using this fleet of drones, which belongs to the FANET lab, which stands for Air Monitoring Image Processing Lab, to monitor wildlife and vegetation inside the San Rossore Park. In particular, my work focused on developing functions for the automatic creation of aerial datasets of wild animals, specifically wild boars, but also fallow deers and wolves. To this purpose, we used semantic segmentation with YOLO-E in order to train wildlife recognition models that are lightweight enough to run directly on the drone's onboard computing units, for example Raspberry Pi or Jetson Nano. We also carried out some night missions using the DJI Zenmuse H30T thermal camera. As for the vegetation, I worked on processing multispectral images captured using the DJI Mavic 3M and the NikaSense RedEdge camera to study several species, among them pine trees affected by the coccinille tartaruga, as well as a variety of medicinal plants found in the park. Using specific processing tools, we are able to analyze the health conditions of vegetation, and we are also carrying out some photogrammetry missions to virtually recreate complex rural environments of the park.
We are researchers at the University of Pisa, working on the Restart project WatchEDGE, which focuses on creating sustainable edge AI networks for remote and environmentally sensitive areas, such as Parco San Rossore. Our goal is to enable real-time wildlife monitoring with minimal environmental impact. I, myself, Sunil Matthew, postdoctoral researcher. I focus on deploying advanced networking solutions in remote areas. In Parco San Rossore, we establish connectivity using a heterogeneous network combining private 5G, Starlink, sub-6 GHz radio links, IEEE 802.11ah, Wi-Fi and Ethernet. Sustainability is key, so our systems are solar powered and designed for low intervention operation.
I am MD Wahidur Rahman, PhD student at University of Pisa. I work on making edge AI nodes more sustainable. We designed a two-layer node, one for sensing, one for processing. Sensors collect data like wildlife activity using a camera triggered by a FEIS sensor. We trained a YOLO V8 model on a custom dataset named European Animal Detection Dataset. optimized for real-time inference, balancing power efficiency, and make the node more intelligent.
Hi, I am Elvisa Marco, a researcher at the University of Pisa. My focus is on depth sensing for real-time wildlife monitoring. We evaluated stereo vision, the time-of-flight cameras, assessing range, accuracy, lighting conditions, and power consumption, and also tested the compatibility hardware with edge boards like the Jetson Orin Nano and the Raspberry Pi 5. This allows accurate animal distance measurement with minimal hardware impact. Together, our team is advancing intelligent green AI at the edge, combining robust networking, smart sensing, and sustainable design to monitor wildlife efficiently and responsibly. Thank you.
I'm Emanuele Petria, a PhD student at the University of Milano Bicocca, and I work in the RES lab. I am currently working in a WatchEDGE project within the Restart program, and our goal is to extend functions as a service model to decentralized environments. To achieve this, we developed and extended DFAS, our platform, to run on Kubernetes and to be deployed on edge nodes. A DFAS node is composed by three components. One is the agent that manage the function execution. The second is the functions as a service platform that execute the functions. And the third is the proxy that load balances the incoming workload across nodes. DFAS can predict incoming workload, can measure performance metrics, and can effectively balance incoming workload across nodes. We also integrated DFAS with the Network Service Orchestrator. This allows us to automatically manage and deploy DFAS on larger environments, and we developed and implemented a generic machine learning function for inference with the image-based use case, where any machine learning model can be loaded and then executed. With this work, our goal is to make serverless computing scalable, efficient, and also suitable for decentralized environments.